Okay, let's start. Hello, everyone. Good morning. Thank you for joining me today in this session about how to test your Java application with Spock. But what is Spock? So Spock is a Groovy-based testing framework for your Java and Groovy applications that makes writing tests fun again. We can write really high, expressive, and beautiful tests because of its DSL and all the power that Groovy provides us. We can write the test better. We can write less line of code to test our production code. And we are going to write very readable tests. Spock is totally compatible with JUnit. So if you are now using, and with your standard tools. So if you are now using JUnit, you can just use Spock. If you use your IDE, IntelliJ, Eclipse, NetBeans, you can use Spock without any problem. And also it's compatible with your standard CI servers, such as, for example, Jenkins. So during this talk, what I'm going to show you is a lot of nice features about the Spock. So maybe at the end, after the talk, you are interested and you want to, or you can introduce into your current projects. But first, let me introduce myself. I'm Iván López. I'm from Madrid, from Spain. I work at Object Computing. OCI is the company behind the Rails framework. Now I'm a member of the Rails team. I've been using Rails and Groovy for the last 7 years now. I'm the coordinator of the local Groovy user group in Madrid, and I also organize Greets, which is a Groovy conference with all the content in English. If you want more information, there is the URL. Here we have a few of Greets t-shirts and a few stickers and buttons. So after the talk, you can grab a few of them. And I'm also a regular speaker at different conferences. I could spend something like 25 minutes in this talk talking about why it's important to test our applications and explaining a lot of theory about that, about unit testing and all that stuff. But I'm going to assume that you all test your applications, right? Are you testing your applications? Yay. And if you don't test them, I'm pretty sure that you know that it's important to test your applications. So I'm a developer, and I hope you are developers. I love to see code, so this is my last slide, because now it's something like a demo time, right? So I'm going to show you how Spocks look like and how you can just start writing a Spock test. So here I have a project. It's built on Gradle. If you use Maven, it's pretty much the same. The only thing you need to do to introduce a Spock on your current project is just add this dependency, Spock core, and that's all. Don't worry about the code. It's already on GitHub. I will tweet and push the link, so don't worry. Spock has its own Groovy version, but here I'm using just the latest one. These lines doesn't exist yet. And I need to add this SLF4j because if not, it's going to be complaining every time that is not an implementation of the class path. But it's not about the Spock, it's because I don't have any more dependencies here on this project. Okay? So I have here some Java code that I'm going to show you how to test it. And here I have the Groovy code or the Spock code to test that Java code. So let's start with the very beginning. If you want to use a Spock, the first thing you need to do is create a class and extends from a specification. This is a Spockline01 specification, and as I said, it's totally compatible with JUnit. Here we are using this runner, run with. This is a JUnit annotation, and Spock has this Sputnik runner. This name, Sputnik, comes from Spock and JUnit, this mixed name. And here is where all the magic happens, but you don't need to worry about it. You only need just to extend from a specification, and that's all. And the first thing you can see when you write a test is that you can write just the name of the test in plain English. You don't need to write this camel case method name that is really hard to read. You just open a quote and write the exact thing that you want to test. And the next thing we have is that we have these blocks, these given when then blocks. Spock follows this BDD approach. So I've seen a lot of posts and a lot of things that people, when use JUnit, they do something like this. They put this in comments because with JUnit you don't have this separation, right? Here you need to specify that. And the first thing I try to do every time I write a test is writing this, given and a small description of what I'm trying to do. And this test already compiles and already passed because I'm just not testing anything, right? But it's a very good way to start thinking what you want to test. In the given block, you put your setup, the things you need to do to start testing things. Then in the when, you put what you are actually want to test. So here we want to reverse a string. And then here in this then block, you put your assertions. Here in the then, every Boolean expression is an assertion. So you don't need to put an assert here. Everything will be an assertion by default. So as you can see, the test pass, it's pretty simple. Given I have this string, when I try to reverse the string, then it is reversed. It's pretty simple to read the test. And this is the standard form, given, when, then. But sometimes this is really verbose, and we have this something like this shortcut, which is using that spec. So I'm expecting that when I reverse this string, this should be the output. Okay? You can mix, for example, have a given and expect. You can mix and match most of the blocks. And the last thing I want to show you about this basic example is that Spock forced us to write our test in this given, when, then form. So I cannot do something like this. When, I don't know, true. If I try to run this, it doesn't even compile. Spock is saying, okay, you cannot do this. You need to follow this given, when, then approach, right? With the JUnit, putting everything in comments, you don't have that kind of force of constraint. So, as I said, you can test Java code with Spock. So I have here this Java code. It's a Fibonacci sequence: 1, 1, 2, 3, 5, 8, and 13. It's an array list of integer, and I'm going to test this Java code, this very simple Java code, from here. So I return the list of names. Here, when I add a new name, this is the same thing as calling the add method, because in Groovy, the left shift operator is overloaded. I want to expect that the number contains 21 because I just added. So this is a pretty simple example. Of course, it's going to pass. But we can do more interesting things. So now I have here this array list of users. So user is just Pollo, name, last name, getters and setters. Okay? And I return here a list of users with these 4 users: Sheldon, Leonard, Russ, and Howard. So now let's see what we can do with this. So I'm going to, let me do this, because we can see the list of users and my assertion. So the first thing I can check is that the list has 4, the size is 4, because I'm returning here 4 users. Then I want to check that the name of the users are Sheldon, Leonard, Russ, and Howard in that order, because, as you know, a list has order. Then I'm going to short the names of the users. So now the resulting list will be Howard, Leonard, Russ, and Sheldon, because I'm using just the default sorting, the alphabetical one. In this line, I'm going to get the last name of the users, and I'm going to create a new list with the size of the last names. This is why I have 6, 10, 12, and 8, because Cooper has 6 letters, Hofstadter has 10, Kotropoli has 12, and Wolowit has 8. And the last thing, in the last line, I'm going to get the name of the user with the minimum, with the less letters. So in this case, it's Russ, because his name only has 3 characters. So I'm pretty sure if you are Java developers, this line, this thing, users.name, is strange for you, because, let me do this, users.name. So these users, as you can see here, it's just a list of users, right? And I'm executing users.name. So it's something like this name thing is on user, and you know that list doesn't have a user's name. So what Groovy is doing here, it's something like executing this method on every element of the users. And you can write this code with this, which is called the spread operator, which is basically the same as the previous one. But we can also write this code in different ways. For example, we can collect, which is something like applying something to a list of elements. And we are going to return a list with the same number of elements. So in this case, this code can be it.name. It is the default name for every variable in each iteration. In a more Java approach, we can, for example, do something like this: user u, user.name, or even user.getName. Okay, in Groovy, we can access properties just like using this. Actually, here, when I write user.name, I'm executing the getter. My code is going through the getter, but it's something like a shortcut. And if we want to try to write this code in a more Java approach, we can just use the stream API. We can map every element. Here in Java, we need to apply or to do a lambda. In Groovy, we have closures. So I could say something like user u dot name. Then I need to collect, and finally collectors to list. And the final, something like the final Java code will be user.getName. So I'm going to run this, and if everything goes well, yeah, you can see that the output is the same in all the cases. Okay, so I'm going to delete all these intermediate steps because I want to show you the difference between this line and this line. Of course, you can read this line, right? You have a list of users, you stream them, you map every user to extract the name, and then you create a new list. But I think that you will agree with me that it's really more simple to write users.list to compare that the users or the list of expected users is that one instead of writing this code here. So I can do here something like this. I'm going to copy this, paste it here, and the test is going to still pass because I am doing the same. Okay? So I'm not saying that this is wrong, but when we are testing a lot of things in an application, imagine that you need to go to the database to get some users and make sure that you are applying, I don't know, a filter. You want to have a lot of help in your test. So it's better, now that you understand that this users.name, it's going to extract the name for every user, it's more simple to write this than write this very long line. Okay? And the last thing I want to show you here is about maps. So here I'm returning a map with 3 keys: name, last name, and age. So let me show you this again. So I'm going to remove the key name, and now I'm going to check, for example, that the map size only is 2 because I have removed name key. The key set now doesn't contain name, and here you have 3 different ways to access a key in a map. This map.get, and the key is the Java approach, but in Groovy we can do something like this: map dot and the key, and it will be also return the key if it's already there. Okay. Next one. So power assets. When we are testing applications, we need to make sure that so if we are doing TDD, the first thing we need to do is to write a failing test and then write code to make that test pass and then refactor the code. So it's important to have a very good feedback of what happens when a test fails, right? So this is a very simple test and it's going to fail, right? So this is what we have in the output when a test fails. So we have every single step of this computation in this case. So 2 times 3 is 6. 5 times 4 is 20, and of course they are false. This kind of output is called power assets, and they were, or this power asset thing were introduced in Spock a long time ago, but as they are such a great thing, they were moved to Groovy core. So now in any Groovy code you have, if you write an assertion and it fails, you will have an output like this. As I said, this is a pretty simple sample, but I have a better one. So imagine that you have this data. This is a map. So this is the key, this is the value, another key, another value, another key childs, and this is a list, right? So it's a map with some data there. And what I want to check is that the name of the first child, I want to check it if it's Adriana. And as this is a list, this test is going to fail because here we have JUnit. So if I run this, you can see here the output. So we have in every step all information to make sure or to understand why this test has failed. So in data, we have all information. Then we get the child. So now only we have this list. Then we extract the name of every child, Judith and Adriana. The first one is Judith, which is not Adriana. So that's why the test failed. So this is really important because when a test fails, you don't want to write a lot of print lines to debug the test or even put a breakpoint and run a debugger. With this kind of output, you have a lot of information of why the test has failed. And here we even have this thing which says, okay, they are 40% similar, although I should say that they are more similar because they are both my daughters, they are siblings. But that's another story. So remember this thing, this power assert thing, because it's really important when you test code. Now let's talk about exceptions. Sometimes we need to test some code that throws or not thrown an exception. So as you can see here, I'm trying to convert foo to a long. And of course, foo is not a valid long value. So this code will throw a number format exception. This is what we are doing here. When I'm trying to convert foo to long, I expect that this exception will be thrown. So if I run this, the test is going to pass. But we can do more things with this. So, sorry. So we can save here the exception, and we can check anything we want on that exception. So imagine that we want to check the message of this exception, which is for input string foo. Yeah, space and quotes. Okay, now it's green. So imagine that here you are using your own hierarchy of exception with a lot of new fields. You add an error code, a different message, and a list of whatever things. You can always check here anything to make sure that the code is failing for the thing that you expect is failing. And as we have this throw, should not throw an exception, we can do something like this. If we convert a valid number, we have this method not thrown number format exception, right? To make sure that now this code doesn't throw this exception. And another thing that we can do is imagine that instead of that, I say that, okay, I'm going to catch null pointer exception. This test is going to fail, and we have here the solution. I was expecting null pointer exception, but instead I got number format exception. So with these methods, you are covered. You can check anything you want relating with exceptions in a very nice way. Data-driven. This thing is, for me, one of the killers features of Spock. In JUnit, you have something, I think it's called Parameterized test, which is pretty much the same, but the code to do that in JUnit is way too ugly compared to this. So imagine that you have one code that you want to test with a lot of different inputs. In this case, my test code is pretty simple. I want to check if a number is even. And in this where block, we introduce variables, in this case number, that we can use in our code. And this code will be executed once per number here in this list, right? So this code, this test, will be executed for these 5 numbers. We can do the same with more than one variable. Imagine that we want to check that the minimum between x and y is this result, so we can just introduce more variables. But the wrong thing or the bad thing with this thing is that we need to read something in column mode, right? The minimum between 1 and 2 should be 1. Between -1 and -2 should be -2. So it's not that readable. So what we can do is transform this in this data table. So it's the same as this one, but now we can read in line mode. So imagine that this test is failing. I can comment these two very fast and just focusing on this one. And if we want to add, for example, a new use case, I can do it. I only need to add a new line. And I don't even need to worry about formatting the test because my IDE is smart enough to do it for me. So I can run the test now. And it's going to fail, of course, because I put just some random numbers. And we can see here that the test has failed, but we don't have any clue of which of these results make the test fail. So what we can do is introduce this unroll annotation. With this annotation, what it's going to happen now, if the test fails, is that we are going to have a new output, a new test result for every line here in the word table. So now we can see that, okay, the test number 2 in this case, the last one has failed. But we can see that It's not very readable because we have this index 0, 1, 2. So we can do it better. And what we can do is replace the name of the variables here in the name of the test. So now, if we run this again, we can see that the name of the test has changed based on here. Let me do this. On the variables and in the name. So it's pretty simple now to go to the test result and see, okay, it's failing because, of course, the minimum between 1 and 0, it's not 6. And the last thing I want to show you about this is that, remember this thing? Sorry. Here I was using a list. This is an array list in Groovy. But you can use anything that is iterable. So what I'm doing here, let me start with the word block. So I have these users. Imagine that this is a CSV. I'm going to add a new user here. So what I'm doing here, basically, I read the file, I read all the lines, and I create a new list splitting by comma. So with this code, what I'm doing is basically I'm parsing this CSV. This is an ugly code, so please don't parse CSV file like this. This is fine because it is a demo, and this is for a test. But for production code, don't do this. Use Java libraries to parse CSV files. So with any line of that file, I'm creating a new list with these two variables, the name and the last name. And then once I have the variable, I go here to the given. And here, what I'm doing, this thing, so this is a map, this is the key, this is the value. And with this thing as user, I'm doing a Groovy trick, it's called coercion. So I'm coercing, I'm transforming this map to an instance of the user class. And this works because user has this name and this last name, these properties. So Groovy knows how to convert this to a user because these keys match the user properties. So the first thing I want to check is that that instance, so this variable is actually an instance of the user, of the class. And then I want to check that the name and the last names in the user variable are the same that I read here. So I can run it. Sorry, I'm not running this. It's green, but we can do it better because we can also enroll here, and we can also write here, we can expand the name of the test here. So I can write something like name equals the name. And as you can see, the IDE knows about this word variable. So I have auto-completion also for the variables, the last name. So if I run this again, you can see here that you have one output for every line in that CSV file. Okay. Mocking. This is really important. If you are using JUnit, you are probably using PowerMock or Mockito or something like that to mock things. So mocking is, imagine that you have this piece of code that you want to unit test, but this code has this collaborator. So you don't want to take care of this thing when you are unit testing this. You are going to unit test this in another place. But when you test this piece of code, this thing, you need to deal with this thing. So one of the possibilities that you have is just using mock. With a mock, we are going to replace this collaborator with something like an empty object. And we are going to check behavior. So we are going to check that this object has been called. We are going to check interactions. So let me show you this example. This is the thing I want to test in the when block. I want to test what happens when I create a user. So this is my Java code. Imagine that I have this method. I receive a name and a last name. I create a new user. I have here a lot of business logic. I store the user on the database. I do whatever I want. And at the end, I want to notify the user, for example, sending an email saying, OK, your account has been created. So when I unit test this code, I don't want to worry about this notification service because I will test this thing in another place. Right? So imagine that this is something like a Spring thing. I'm not using a Spring. This is just plain Java, but I have this collaborator and I inject using a constructor. And this notification service is just an interface. I don't have an implementation. I don't need it for this demo. So what we can do here is I'm going to create a mock of my notification service, my interface. And now I'm going to instantiate my user service with this mock instead of using a real implementation. So what I'm going to check when I execute this is I want to make sure that the method send notification is executed once and only once in this mock. And I'm also going to check that the second parameter is user created. I don't care about the first one, but I want to make sure that this is the same message. So if now imagine that tomorrow I refactor this code and I forget to notify the user, what is going to happen now is that this test is going to fail because I was expecting one execution in this mock, but I got 0, right? So you can also check. So here I was, with this underscore, I saying, OK, I don't care. But we can actually test these things. Because here, let me do this. Here, I create the user here, which is a local variable inside this method. So I cannot access user from outside. And I'm using this user here. So one thing I can do with Spock here is writing a closure with some Boolean condition that I want. So I know that I have a user there, so I want to check that the name of this user is Iván because it's the one I'm using here. So if I create a user with another name and I don't modify this, now the test is going to fail, saying, again, I have few invocation for this, but there was another invocation which is a match. So maybe this is the thing you are looking for. Okay? And in these both cases, I was mocking an interface. But in some cases, you need to mock an implementation. Because, for example, you cannot create an interface or the, yep. This example? Oh, it means that I'm expecting here that the username is Iván, but here I'm creating a user with another name. This is why it's failing, because I'm accessing the user here. So here, IT, it's the user variable. OK, perfect. So yeah, sometimes you cannot mock. You don't have an interface. Because imagine, so this is my code, but maybe this is from an external third-party library, and you only have the implementation. There is no interface. But you need to deal with it. So to do that, sorry. Remember these lines here. So let's do this. You need to add CGLib on the class path. With this library on the class path, you can now mock implementations. Don't worry, because if you forget to add it, Spock will tell you. Once you try to mock an implementation, it will say, OK, I don't know how to mock an implementation. I think you need to add CGLib on the class path. And now with the library on the class path, you can mock an implementation, and it's the same. I created a mock for my implementation, so when I call this method send email, I can check that it has been executed. OK? And the last thing is about the order. Imagine that you are sending 3 messages, and you want to make sure that those 3 messages are received in the same order. So message 1, message 2, and message 3. You need to put here 3 different then blocks. This test is going to pass. And if I do this, and if I send first the message 2, and then I check message 1 first, the test is going to fail. OK? But this is because you have 3 different blocks. If you put, if you put this in the same then block, the test is going to pass again. Because Spock only takes care of order when you have different blocks. If you have all your assertions in the same block, then it will match something like, OK, I have message 2, 1, and 3. They are here. OK, green. So taking into account that when you want to check something like this, you need to put more than 1 then block. And stabbing. So the other thing to deal with this collaborator here, the first one was mocking, the other one is stabbing. So with an stab, what we are going to do is replace this object with a fake one that will return something that we need to continue testing our code. So as you have seen, I haven't introduced any dependency. A mock and a stab came with a Spock, so you don't need to add any other dependency to do that. So imagine that I have now here another interface, user repository. I have this method, find by ID, receive an ID, returns a user. and find all by last name, receive a last name, and return a list of users. Something like to go to the database to look for users. So what I can do here, I can stop that repository, and here what I'm saying is, okay, every time I call find by ID, and I don't care about the ID, please return this user. You need to make sure that the signature is the same, so I need to return a user, okay, because this is the signature of the interface. So I just return a new user. So now if I call this find by ID in the stub repository, Spock will return this user, John Doe. We can also do the same. Imagine that we need to call the same stub object more than once. So we put here we're using the right shift operator and just return the user. Here we are using this operator, which I don't know the name, and we put here a list of users. So in every iteration, Spock will return one of the users in this list. So for the first one, Spock is going to return the first, which is John, and for the second, it will return the second element of the list, Jane, and for the third, for the fourth, and so on and so forth, it will return the last element of the list. That's why here, when I call the stub method another time, it will return again Jane, because it's the last element of the list. We can also return different objects depending on the ID. So in this case, I define that when I get this ID 20, I'm going to return Jane, and with 11, I'm going to return John. So it doesn't matter if I execute first 11, this will match by ID. So 11, this first execution will match this. So for the user 1, I'm going to return John, right here. And for the user 2, I'm going to return Jane. We can also throw an exception, because sometimes we test this code and we want to make sure that our calling code deals properly with this exception. So we put here a closure, and inside the closure, we just throw the exception we want to check, or we want to mock, or stub in this case. So when I execute this method, I expect, as we saw in the previous example, that this runtime exception has been executed, and this is exactly the message I have here. So if I change this, the test will fail, because you can see here, expected user does not exist, actual users does not exist, with exclamation marks. And the last thing about this is that you can stub more than one thing. So in this repository, in this interface, I had these methods, but I was only using the find by ID in all the examples. But you can use you can stub all the methods that you need for your specific test. So in this case, I'm going to return this Peter Smith user, and I don't care about ID. And with this find by last name, I'm going to return this list of users. Please don't confuse this thing with this. This is to return different users in any interaction. Here, I'm just only using right shift, and I return a list of users because, remember, I need to honor this interface, which returns a list of users. So when I execute the find by ID with any number, it will return Peter Smith. And when I execute the find by last name with Doe, it will match this thing, and the size will be 2 because this list has 2 users. Okay, next one. How are we going? Okay. So life cycle, this is pretty simple. Spock has a life cycle in which you can hook to do a lot of things. So I have these 2 tests that just print test and test2, and we have these methods. We can implement any of these or whatever we want. So setup expect will be executed only once at the very beginning of your class. Then setup will be executed every time before any test. Cleanup will be executed after every test, and cleanup spec only at the end. So if I run the test, you can see here, setup spec once at the very beginning, cleanup spec only once at the end, and then setup, test, cleanup, setup, test, cleanup. So you can use this method, for example, to initialize common object, to open, I don't know, a connection, and then to close a connection to the database or something like that. Oh, this is pretty good. Okay. Now imagine that we want to check what happens when we add a new number. So this is how you write this Fibonacci sequence in Groovy. This is an array list, and I want to check what happens when I add a new number. I want to make sure, imagine that instead of using the Java util list, I'm using my own implementation for whatever reason, and I want to make sure that the size of this list has been increased once I add a new number. So we can probably do something like this. Number size equals numbers.size. I store the size of the name of the list. And now I want to make sure that the size is the old value plus 1. Sorry. This is like this. Right? This is passing because it's obvious. But doing this trick, or the other way, we do this trick because we are developers and we think like this. Okay, we know that we are modifying here the size, the list. So if we want to check anything before, we need to save this here, right? We are developers, we think like this. But regular people don't think like this. So what you expect here is that the size of this list should be the old size plus 1, right? This is how the human brain thinks. The old value plus 1. We do know that we need to do this trick. And when we use this old method, Spock is doing just exactly the same I did. He sees this old in the then block, so Spock is going to something like copy and paste this thing to the given. It's going to evaluate, going to save that in a temporal variable, and then use it here in the assertion. But we don't need to do this. So this all it's not that, I mean, you don't use this every day, but sometimes you use it and it's pretty good to not doing this kind of hack. Okay, 3 minutes, shared. I have more examples in this project, but the first one are the really important, so don't worry about a few of them that I don't have time to show you. If you have some question about any of the other examples, just drop me an email, send me a tweet, and I will help you. So this is my last example. Imagine that you have this user and you want to share this user in all the tests. This new user is something like, it's cheap to do this, but imagine that you are instantiating a very complex object, so you have an expensive thing here and you don't want to create that user or that thing every time for every test here. So if you do this, you declare the user here, you can see that they are different users. So the first thing that you can do, or you can think is, okay, let's use one of those methods, this setup spec thing. So we can define here user, and here do setup user equals. So if you remember, setup will be executed. What is it? Okay, yeah, I was running, sorry. I was trying to run setup method. So setup is executed once before each method, so it makes sense that the users are still different. So okay, we can make think, okay, let's use setup spec because it will only be executed once at the very beginning. If we do that, the test doesn't compile. And we have here the solution. Only shared and static fields may access from here. So what we can do is do something like this. Def and we can use the @share annotation. So with this annotation, we are doing two things. The first thing is that we have the same user, that this is what we want. And also we are something like documenting the code, because in the future, when you or one of your colleagues read the code, she will see this code and she will thought, okay, this is shared, so I need to be careful because this user will be used in all the tests here. So maybe I don't need to modify, or if I modify this thing, I need to make sure that everything is working. Okay? And now the last thing I want to show you before finish is this thing. This Spock Reports. So what I'm going to do is run all the tests. I don't care if some of them pass, fail, whatever. And I want to show you the reports. So open with, no, Opera no. Firefox. So this is the standard Gradle report. You can see here all the information, the classes, the test that has failed, that has passed. But with this Spock report dependency on the class path, we also have this output here. I'm open this, Firefox. So it's pretty much the same, but there are two different things here. Remember this first test. In the first test here, I wrote labels in the given when then block. Here, I have the labels extracted to my test result. And also in this data-driven, which is the table, here I only have this output, but here I have all the table with all the information. And the nice thing about these Spock report things is that you can customize everything. You can provide your own logo, your own CSS, your own whatever you want. So you can use this to create something like reports for business people that may don't understand the code, but they can probably read this thing and understand. Okay, so these are the resources: the Spock framework web page, the GitHub repo, and the documentation. The documentation it's pretty good. There are a lot of examples explaining everything. And that's all. This is my contact information. The code is already on GitHub. If you have any questions, just drop me an email, send me a tweet. I will answer you. And if you have something like 30 seconds, please go to that URL. It's the same in this QR code. It's an anonymous Google form to send me just some feedback about the talk. It's only 4 questions. So if you like the talk, let me know. If you don't like it, just let me know. Send me some feedback. It's anonymous, so you can say anything you want. And if you have some questions, I think we have maybe time for a couple of them. And if not, I will be here almost for the rest of the day. Thank you very much.